Today we will discuss about mobile ad hoc networks. A mobile ad hoc network manet is an autonomous system of nodes connected by wireless links. These nodes are called mobile stations. And a manet does not necessarily need support from any existing network infrastructure like an internet gateway or other fixed stations. The network's wireless topology may dynamically change in an unpredictable manner since nodes are free to move in manets. The information is transmitted in a store and forward manner using multi-hop routing. This is a figure of a mobile ad hoc network. It consists of several mobile stations. It is indicated in this figure as MS, and each mobile station can communicate through two links, that is either using symmetric link or asymmetric link. The symmetric link, as we seen in the picture, that in symmetric link both the nodes can communicate each other, that is both the nodes can act as a receiver and a transmitter. Such links are called symmetric link, but in asymmetric link only one can transmit the data and the other can receive it. That is, two types of links are available in mobile ad hoc networks. Next one, each node is equipped with a wireless transmitter and a receiver with an appropriate antenna. That is, each node can act as a transmitter and a receiver. We assume that it is not possible to have all nodes within each other's radio range. When the nodes are close by, that is within radio range, there are no routing issues to be addressed. That is, the problem of routing issues arise only when the nodes are not close. At a given time, wireless connectivity in the form of a random multi-hop graph exists between the nodes. Then the characteristics of ad hoc networks. The main characteristics of ad hoc networks are, first one, dynamic topologies. That is, the topology of the manet is changing. That is, each node in the manet is moving. That is, we can say it is a dynamic topology. The network topology may change dynamically as the nodes are free to move. Next one, bandwidth constraint or variable capacity links. Realized throughput of wireless communication is less than the radio's maximum transmission rate, and the collisions occurs frequently. Next one is energy constraint operation. Some nodes in the ad hoc networks may rely on batteries or other exhaustible means for their energy. Next one, limited physical security. That is, the manets are more prone to physical security threats than fixed cable networks. These are the main characteristics of ad hoc networks. Next one, routing in manets. The main goals: provide the maximum possible reliability, that it uses an alternative route if an intermediate route node fails. Then choose a route within the least cost metric and give the nodes the best possible response time and throughput. The route computation must be distributed, that is, everyone should participate in the route communication, and the centralized routing is in a dynamic network is usually very expensive. The routing communication should not involve the maintenance of global state. Every node must have quick access to the routes on demand, and each node must be only concerned about the routes to its destination. That is, every node only knows or only worries about the route to its destination, and the broadcast should be avoided. That is, the broadcast is highly unreliable, so in manet it should be avoided. It is disabled to have a backup route when the primary route has become stale. Next one, the routing classification. The existing routing protocols can be classified as two, that is, proactive and reactive. The proactive routing means when a packet needs to be forwarded to some nodes, then only the route is already known. That is, in proactive, we already knows the route and we can transmit the packet whenever needed. But in reactive routing, we does not know the route to every destination. That is, a route is determined only when one sender wants to send a data to another node. That is the difference between proactive and reactive routing. The main type of routing in Networks-Manets is done using the table-driven routing protocols. That is, in each node maintains routing information to all other nodes in the network, and when a topology changes, the updates are propagated through the network. The examples of table-driven routing protocols are destination sequenced distance vector routing, cluster head gateway switching routing, and the wireless routing protocol. We will discuss about it later.